Spacetime Decoded, Part 2. If you have not watched Part 1, then please watch it. What we find in last video is that gravity may be result due to opposite force exerted by surrounding particle trying to restore equilibrium after being displaced by mass. In this part, we focus on how time can be affected by these particles. Many great scientists have explored the nature of time from different perspectives. 1. Isaac Newton, 1643-1727, proposed absolute time. Time flows uniformly everywhere in any universe, independent of motion or matter. Quote, absolute, true, and mathematical time, of itself, and from its own nature, flows equably without relation to anything external. 2. Hendrik Lorentz, 1853-1928, developed Lorentz transformations, showing how time and space change with motion, a foundation of special relativity. Predicted time dilation mathematically before Einstein unified it. 3. Stephen Hawking, 1942-2018, proposed imaginary time and time's arrow, explaining why time seems to move forward, related to entropy and the Big Bang. 4. Julian Barber, B. 1937, proposed that time is an illusion, and only changes between configurations of the universe exist. Time is derived from change, not fundamental. We try to find out time by particle pressure theory, but first we check how we measure time. Mechanical clocks. 1. Pendulum clocks measure time using a pendulum's regular swing. Microscopic basis. Atoms in the pendulum obey Newtonian mechanics. Their vibration and inertia control swing. 2. Balance wheel clocks. A spring-driven wheel oscillates back and forth. Again, the motion is a result of atomic-level elasticity of metal. Electronic clocks. 1. Quartz clocks. A quartz crystal oscillates when electric voltage is applied. Microscopic. Oscillation comes from lattice vibrations of the crystal, atoms moving in a precise pattern. 2. Atomic clocks measure time using the vibration of atoms, for example, cesium, rubidium. Example, 1 second 19263-177. 0. Oscillations of a cesium, 133 atom. This is the most direct connection to microscopic movement, as atoms themselves are vibrating or transitioning energy levels. Every biological process, including thinking, aging, and all life functions, ultimately depends on atomic and molecular movement. 1. Thinking. Brain activity. Neurons communicate using electrical and chemical signals. These signals are caused by ions, like moving across cell membranes. At the microscopic level, these ions and molecules move according to atomic forces and vibrations. Energy transfer, neurotransmitter release, and receptor binding all happen because atoms are moving and interacting. 2. Aging. Aging is the result of gradual molecular damage, DNA mutations, protein misfolding, oxidative damage. All these processes depend on atomic-level interactions, breaking and forming chemical bonds. The speed of these atomic molecular processes determines the rate of aging. Key insight: every life function, from thinking to growing to aging, is a chain of microscopic particle movements. Time for us biologically is felt through these atomic processes. Faster the movement of microscopic motion. It felt time moving faster, slower. The movement of microscopic motion. It felt time moving slower. Since time originates from microscopic particle motion, any factor that changes this motion changes the rate of time. In regions of higher particle density, near massive bodies, atomic movement is resisted by greater particle pressure, leading to slower internal processes and thus time dilation. As per particle pressure model, space is filled with tiny particles that press on all matter. Near a massive object like Earth, particle density and pressure are higher. These particles resist or slow down atomic vibrations slightly. Time dilation is not a change in time itself, but a change in rate of all physical and biological processes due to slowed microscopic motion. In simple words, time not slow down, we slow down, we slow down. In upcoming videos, we will explore other phenomena in universe by particle pressure theory. Stay tuned.